Hello all. I hope everyone is doing well. Can you let us know? Can you hear us? Can you see us? We've had a few technical issues trying to get going. You may notice it is Paolo with us today, not Spencer. Spencer's on holiday, so Paolo's come to join us. So I hope everyone's doing well. Again, here we are live from the Tech Centre. For those of you that don't know me, my name is Richard Stubley, and I'm a process specialist, and I'm joined today by... That way.
Hello, Paolo Bastianelli. Not in the tech center, a bit far away. I'm based in Rome. Probably some of you may remember me from other live streams, but today I'm filling in for Spencer. Another thing I need to make sure you are aware of that whenever Paolo Bastianelli will reply in the chat is basically me as Fusion 360, but for some reason um, I have to go with my personal account because the Fusion 360 account is not working on my laptop.
Yeah, so again, sorry about that. That's why we're a little bit late because Paolo is. I think the fact we run through VPNs, it probably thinks that he was trying to hack into our YouTube account, so it kept throwing him back out of it. So again, if you do see Paolo Bastianelli replying, that's normally what Autodesk Fusion 360 is. Can you all see us? Can you all hear us? Is everyone there? Hopefully everyone is today. This is going to be a very interesting one. We're going to start looking at how we can actually do a lot more than just program NC code just to run the machine. We're going to actually look here at programming NC code to do logical commands on the machine. So quite a nice way of actually doing things differently. We're going to have a quick look at the machine, have a look at what we call macro variables, among other things, and we're just going to check everything works well, make sure we can all make a cycle counter. I'm going to be talking very specifically about the HAS controller because that's what I've got here to show you today. But I'll be trying to make paradigms with other controllers as we go and explain what that's like on other controllers. But everything's going to have slightly different ways of doing it, all the controllers are. So please sort of take what we're looking at today as a bit of a lesson in how this can be done. And then you'll have to convert this into what works well for your machine. So the whole point is we'll be able to, at the end of this session, make a cycle counter to create everything to create a cycle counter. So every time you do a cycle, it adds one to the number. And we're then actually going to make it looking a shift report to print out the date and time each cycle was started. So that sounds fun. So let's dive straight over to the machine. Let's have a quick look, and I'll start talking through what are these macro variables I'm talking about, what on earth does it mean. Please let us know in the chat if there's any problems with the video or audio. So there we go. Right, again, because of COVID, I'm doing this on my own, so I'm the camera person and the presenter, so it's always good fun. So this is our control here now. We've got empty spaces on our controller that we can store and do things with data, be that calculations, be it printing out. And on a HAS and other FANUC type controllers, they're referred to as macro variables. On a Siemens, they're called R variables. On a Heidenhain, they're called Q parameters. So you can see each machine calls them a different thing, but in essence, they all do the same kind of job. So let's get really close in now, and let's try and see if you can see what I'm doing. Again, let us know if this format doesn't work well and you can't really see what's happening. Again, I am not the best cameraman in the world by far. So what I'm going to do, I'm going to have a quick look at our macro variables list. So on a HAS, you go current commands, and then you've got to go up to the macro variables tab up there. So I'll go current commands again, over to macro variables. And what you can see now is we've got local variables, which are 1 to 33 on the left here. Now these are what we call volatile. What that means is that when you do a program, they all go back to this empty value. This is brilliant if you want to do something as a one-off calculation that you don't want to keep. These are the perfect places to do that in. And the reason why you do that is because you know you're not interfering with anything else. We start looking here at the system variable. So if we go across, we can see there's data stored in these system variables. So how do I know if I overwrite that I'm not ruining something in the machine? You've got to think these parameters are where everything gets stored on the machine, all the data, all the tool length, all the work offsets. You've got to be sure that you're not destroying someone else's data. We look We go over to my favourite subject, probing, and if I go down to 500, where are we? Here we go, 550. Let's keep going down a little bit further. Here we have the probe calibration data. So the last thing I want to be doing is overwriting these values here. So that's why the local values that we saw on the left were so good, because we know that they are free for you to use inside of a program. No one else could have used them, but bear in mind that they get emptied at the end of the cycle. So for a cycle counter, that's no good, because we're going to lose that every time we do the cycle. But that's a really good thing to know that we've got this area to play with here. So let's do our first ever step in macro variable programming. I'm going to go into MDI, and I'm going to create us a really nice simple program. So I'm going to go hash, which is the symbol for a macro variable, hash1 equals 1. I'm going to end a block and input that in there. I'm now going to do a really easy one. I'm going to go hash2. Can anyone guess what that one's going to equal? Yes, 2. Well done. End of block, enter. Now, I'm going to do a different thing. Now I'm going to go hash3. Can anyone guess what I'm going to do here? Right, I'm going to do hash2 equals hash1 plus hash2. End of block, enter. Paolo, have we got anyone saying they can't see what we're doing, or is this okay at the moment?
No, it seems fine. Everyone seems to be able to see us and hear as well, because nobody's complained so far.
Well, that's good.
We had good comments on the t-shirts we're wearing, though.
I must admit, we didn't actually, unless Paolo saw what t-shirt I was wearing this morning and has changed to match, we didn't actually plan to both be wearing the same t-shirt.
I guess working in the same team, having access to the same sort of swag, we would have the same t-shirt, no?
Yeah, we would. Right, so I'm in MDI, I've put single block on, and you can see now the macro variables are all empty. I've got single block on, so if we run the first one, there we go. Now that's really important what's just happened. I have just done single block, run one line, and it's actually run all 3 lines. That is because there is something called look ahead. So to make NC machines even quicker, they look ahead lines of code. And this is to make sure that they accelerate and decelerate in the most efficient way. Because when a machine has to change direction very quickly, it has to decelerate into the turn and accelerate out of the turn, exactly the same as a racing driver. So what the machine is doing here is it's looking ahead and going, oh, I'm going to work out all these macro variables for you. Well, that's brilliant, but that can sometimes cause us problems if we need to do calculations in a sequence, but we'll talk about that in a second. So what you can see now, we have populated... Oh, yep.
We've been asked if we could zoom in on the screen a little bit.
Yeah, not a problem.
Thank you.
Let me move that again. How is that, everyone? Please let me know again. I get very little. I've got a little 3-inch screen on the camera I'm looking at here, so I can't see much.
I don't think it has zoomed in at all.
Okay, right. Let me sort this out even closer.
It's too much. Maybe come a bit outwards.
Yeah, I know. How's that, everyone? So if I can go...
Now it should be fine.
Cool, perfect. So what we've got here, we've got hash1 equals 1, and you can see hash1 equals 1. We've got hash2 equals 2, and hash2 equals 2. And then hash3 equals hash1 plus hash2. I mean, again, I know this is teaching people how to count 1, 2, and 3. But you can see here, these are the building blocks of what we need to know to start doing logical processes on our machine controller. But what you can imagine here now, let's get to the end of this. So I'm going to go cycle, 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 cycle. And you can see now I've got to the end of my cycle and I've lost all of my data. So everything has just gone back to 0 because they are volatile variables. So again, they're brilliant for things inside of a cycle where you haven't got to worry about using them afterwards. But if you need something afterwards, you need to use non-volatile variables. And on our Haas, that happens to be anything above 10,000. So we're now going to do some non-volatile programming. So things we're going to keep. So let's just move that screen ever so slightly to there. So again, we've got lots of data here in these other sections. Now, as a rule of thumb, if it's 0, it tends to mean it's up for grabs and it's free. If it's got a value in, I would never touch it. So let's have a quick look here. So I can see that 10,060, I've got a couple of empty variables there. So let's go back over into my MDI. Let's erase all this program. And I'm going to go hash, where am I? I can't find the keys here. Hash 10,060 equals 1. End of block inserts. That's what I've got there. 10,060 equals 1. And let's have a quick look at those macro variables again on the controller. And I'm now going to do 10,061. So shift hash 10,061. And I want to say that equals, so shift equals, hash 10,060 plus 10,061. You'll see this appear on your screen very shortly, so don't worry that you can't see this. I've got an invalid number in there, so that is the problem when you're writing these out manually on the controller. If you do mess up with what you're doing, it means that it ruins everything you've just typed. So let me type this in again. 10,060 plus hash 10,061. End of block, enter. Okay, it doesn't like that as well. I'm doing something wrong here. Let's find out what this is. Let's do some fault finding. Let's try and put this calculation a bit easier for us. So let's go 10,061. There we go. It really doesn't like that. That's 10,061 there. I'm obviously doing something wrong here. These are the brilliant things about live streams, aren't they? Is that you just see me playing around on the controller when I can't work it out.
I think that's why they're here.
They're just here to watch me faff around. So let's zoom out so you can watch me faff around even clearer. Right, so I'm trying to get 10,061 here, but I can't. Let's work out why. So I've got an invalid number on the controller. I mean, you wouldn't have thought that I've tried this about 6 times this morning and it's worked every single time first. Let's just have a quick look and see where I'm going wrong here. 10,060. I think I know where I've gone wrong. Have I gone 10,600? Let's have a quick look. No, 10,060. Right, back into MDI, everyone. Bear with me on this. I'll get it right eventually. Right, so hash 10,061. Let's just make that equal 1, just to make things nice and easy. 10,061 equals 1. End of block, insert. Okay, it's put it in that time. I must have been doing something very foolish on the controller there. I think it's Paolo that's the bad omen. Does anyone remember his steep and shallow one that we did first, where you couldn't see any of the fusion dialogues? Anyone would think we don't do this for a living. So we've got 10,000...
Easy to blame the person that's far away from the control.
Oh, it's very easy to blame you, Paolo. So we've got 10,061. What I want to do now is I want to make 10,061 equal 10,061 plus 10,060. So what it's going to do is go, if it's 1, it's going to plus 1 to make it 2. If it's 2, it's going to plus 1 to make it 3. And that's our basic cycle counter that we're going to start building everything off today. So again, let's try and type this in right. Equals 10061 plus hash 10060. Right, now let's see if I get this right. There we go. Crikey, that shouldn't have taken me that long to type that in properly. So hopefully you can all see that. So what we've got now is 10,060 equals 1, and then 10,061 equals 10,061 plus 10,060. So that is a really basic cycle counter. Let's put some M0s in just so I've got some space at the end of the program. Let's pop an M0, because an M0, by the way, is a stop. And when you're programming logic, M0s are really useful because what they do is they stop that look ahead from happening. There is an automated way we do that in a minute, but that's a nice, easy way when we're running an MDI, everyone. So, here we go. Let's run this in MDI. So we've got a single block on. That 10,061 should equal 1 in a second. I can see the zoom going crazy on the camera there.
Yeah, I was gonna tell you, it's just starting to go a bit crazy on focus.
I hope everyone appreciates that we're really trying to do something a bit different here. And if it's not working, we'll try it again better next time. So we've got
I think
10,061 equals 1. And now the next one is equal 1 again. So that's brilliant. Let's cycle round. Now we're going to run that again. We're going to run it again now. We should watch that equal 2. There we go. See, that's equal 2. Let's run that again, equals 3. Run that again, equals 4. Equals 5. We have just made ourselves a really basic cycle counter. So, should we end there, Paolo? Should we just call it quits, or should we carry on?
well, I think people are enjoying this. This thing, it's valuable. It's good content. So.
Okay, but are people actually thinking that these cycle counters are useful things to have?
Well, I guess so. We've got people watching us now, so.
Ah, perfect. Well, thank you, everyone. We really appreciate this. So
So
let's.
we had requests to basically show also where you're typing, but obviously only having one camera, we can only show either the screen or the keyboard. It's a bit hard to show the both.
Yeah, I figured you don't want to watch me just pressing numbers on the keyboard, but
Yeah, exactly.
you can see here, everyone, that I'm just running this over and over again now, and it is just keeps counting up. So that is a really basic cycle counter. So we're now going to jump over into Fusion. I'm going to go back to what I know doing is using the software rather than the controller, and we're going to see about what else we can do using something called manual pass-through. So right, let's head back over there and let's jump into Fusion. Oh, I'm going to need a day off after this one. Right. Okay, let's go to Fusion and the camera there. So, hopefully you can all see Fusion nice and clearly. What we've got here is just a basic block of material that I'm going to probe the Z with. I'm then going to face it off. I'm going to do a 2D contour pass and a drilling pass in there as well. So that's all we've got on there. We are then going to do something at the start here. So let's have a quick look at this manual pass-through. If any of you out there don't know what manual pass-through is, it's a really powerful tool that you can use to actually influence the NC code outside of the post-processor. So what you can do is you can go Setup, Manual NC, and then you can either just put program comments in. Program comments are so useful just to be able to, give a bit of extra information to the person running the CNC machine. And you've got stops, optional stops, all sorts of stuff on here. And then pass through is the one we're using today. So pass through is a way to actually pass through the exact text that you enter. So if we're going to have a quick look at what I've got on here, this is a little bit more than the cycle counter, so I'm going to stop jumping ahead of myself actually here, because I keep jumping ahead of myself far too much. Let's go back to manual NC. Let's do pass through, and let's write out our cycle counter again. So we're going to use just some different variables. This time we're going to do 10,062. We're going to make that equal 1. So people are probably saying, why don't I just keep adding 1? Why am I making it equal the other variable? Some people might want things to count in 2s, because if you're making 2 parts per cycle, you want it to count in 2s. So at least this way it lets me change the integer that I increment by every time. I'm now going to do hash 10063 equals hash 10062. If I get the hash right, it's even better. Plus hash 10063. So that is exactly the same cycle counter as what we just did on our controller, but we've just programmed it through the manual pass-through at the moment. So I'm going to hit OK on there, and I'm just going to call this cycle counter. What's the sentiment out there, Paolo? Are people enjoying this one?
Yeah, we're having we just had a comment asking, why can't we get a direct screencast from the machine? But I think we're meaning some real live cutting, which we have done in the past.
Yeah, that's what we're going to be doing in a second. We are going to be live cutting in a second.
Yeah, just give us some more time to get there.
Or I wonder if they mean you can actually network into the HAS and show the actual controller itself, which, yes, that is brilliant, but I'm going to focus more on the machining side than the controller side. So, but very good point. I'm definitely going to take that on board, and I'm going to see how much effort it's going to be for us to then have another video source running through OBS. I wish I was a better video presenter to get this running for you. So I'm going to make an NC program now with the cycle counter and all my toolpaths. So let's quickly call that toolpath number 2. Let's hit post. And let's view NC code. So perfect. Let's have a quick look at what this looks like. We should now hopefully see our cycle counter embedded into the NC code. And look at what we've got here. At the very start, we've got our cycle counter. So we've got 1000 and 10,062 equals 1. 10,063 equals our increment integer. So this is our increment, basically. That's how much we're going to increment, and then this is our counter. So again, I could actually put that into my pass-through on Fusion. So we're going to increment by 1, and then the counter's going to keep counting up by 1. So should we actually go and try and run this? I haven't run this NC code yet. The technical difficulty stopped me doing a practice run. And also, for those of you that know, we did the AU laptop stands. I've been making laptop stands all week, and yeah, there's a lot of them, so I haven't had a chance to try this. So you're watching me run this NC code for the very first time, which I hate doing live. I'd much rather have run it first, once myself. But I'm sure you all trust me. Nick doesn't, who is our workshop manager. Right, let's zoom out a bit so you can see me properly. Hey, there we go. And here we've got our machine, we've got everything else. So we're going to put our USB stick in the machine and we're going to get that code up and running ready. And you're going to hopefully watch me not crash the machine in a second. Can you see the machine okay, Paolo, or is it worth me giving the screens even more of a clean? I did clean them a bit, but I can clean them even more if you can't see in very well. What do you reckon?
Well, give us a few seconds so that I can see a better updated version of the.
Yeah, you get the delay on your side. It's brilliant fun.
About 15 seconds, maybe 20 seconds. But for now, it seems okay. I mean, I can see the part. Unless you change the angle, then I think we should be fine.
Okay, perfect. That should be okay on that. I was finding the program on the USB memory. So, what have people been making at the moment? Have people been making anything interesting that we should know about? It's always nice to hear what people have been doing. We have a Cam Christmas challenge running at the moment, everyone, which we are really interested to tell you. If I'm going to give Paolo the link, and he's going to quickly show you what that actually is. So what we're asking you to do is we're asking you to design a Christmas decoration, and we're then asking you to actually post back on Instagram the design of the Christmas decoration, and the winner will see me live machine it in one of these live streams. So hopefully that will be someone out there listening today. So we'll quickly grab you that link and we'll chuck it in the chat for you. But I'd really appreciate if anyone wants to join in with a bit of fun, a bit of Christmas cheer. It would be very much appreciated.
Same competition, right? Healthy competition. So.
Yeah. So if you want to know sort of why I've suddenly come back to the computer, I've got quite an interesting thing now. The file has just, I mean, this is not a good day for me, you can tell. The file has just corrupted itself and has put every single line of NC code as a different file in the USB stick. So,
interesting.
Yep, never do things live. God, this live stream is not going well for me today. Right, so I'm just sorting that out on the USB stick. But yeah, again, if any of you would really like to join in with our Cam Christmas Challenge, I'd really appreciate that. It would be brilliant to have some of our regular viewers on here join in and make the Christmas decoration. And then again, you'll see me, hopefully a little bit smoother than today, start making that on a live stream. So I'll look at how I fixture it, the tooling considerations, and then you get to see your item brought to life. So that is what really this was all about. I know a lot of people out there haven't got CNC machines, and would really like to see how their designs would actually come to life. So right, hopefully I've now recovered that NC file. That was a bit peculiar. I've never seen that before. A file getting completely split up into each line.
Rich, is it the Instagram link you want me to share with everyone?
Yeah, can you get hold of that?
Yes, I
Ah,
could.
perfect. That would be brilliant, Paolo. Right, everyone. So here we go. Let's try and see if this actually works now. I've never had that problem before. Right. So brilliant. We've got our NC code now. So we've got our NC code. What's going to happen is we're going to probe the top of that block. We're going to face it off, do 2 or 3 of the milling ops, and I've set it up so I can keep running it, and it's just going to keep taking 2 mil off the block every time. And then what we can hopefully see is that cycle counter increasing. We're going to make sure that we're happy with the cycle counter, and then we're going to go into the last thing of making a shift report. So right, what I always do is I would never start the machine like that, because I've seen far too many machines plummet down as the first thing they do. You've got something wrong in the code, and I definitely don't want to plummet down. So we're going to move it over in Y and then up in Z. We were having a conversation the other day, and everyone was sort of sharing their NC worst nightmares, and there were some quite interesting ones. I think the worst one I ever had was when a jaw broke in a lathe, and the part came flying out and left a very big dent in the door and brown stains on my trousers. So let's get that program running. We're now going to start
Richard,
machining.
Akash wants you to know that they're with you and they all like your live stream, regardless of this technical issue.
Regardless of the technical issues, well, thank you very much. That is lovely to hear.
Well, that's a bit about it, but that's what I'm assuming you referred to. We like all of his live streams, so all the support is with you, Rich.
Thank you very much. We do try and do things live because we think it just shows that life's not always perfect. We want to make sure that we're trying to show you what real life actually is like on the machines and program it from Fusion. And hopefully, these live streams do show that we have problems as well, but it's not the problems you have; it's how you solve them. That was what I was always taught when I was an apprentice. You can have as many problems as you like, as long as you know how to solve them. They're not problems. I'm getting a bit philosophical for live streams at the moment. Right, so let's get ready to run. Here we go. I'm gonna run this really slowly for this first one, everyone, because the last thing I'm doing is smashing it all on the live. And the way this live stream's going today, it's gonna happen. So you best be watching because you can get some money off you being framed. For anyone in the UK that knows what that actually is. So I'm gonna probe the top of the block. It's gonna set my Z0 at the top there. I'm now gonna go and grab my face mill. Again, apologies for running this a bit slow, but I always run NC code slow to start with, because you never quite know what's going to happen. I've had far too many machines do some weird and wonderful things on me to trust them. A bit like I don't trust gravity, for anyone out there that remembers the last live stream. So there we go, we're going to face the top off the block now. We're going to go across 2 passes, that's all we need to do to face this block off. And then we're going to do a contour pass and a drilling pass. And what we're going to do is we're going to run this a few times and then have a look at that cycle counter increasing. And then we're going to talk about a little bit more we can do with that NC logic. So for anyone out there that does anything with probing, this is the basis of everything we do with probing. We're using these macro variables to store the data for where we triggered, and actually then we use that to give us back those inspection results. So it's really powerful, all this NC logic is. We're only touching upon it today, but hopefully we're giving you the building blocks to think about what you can do in your shops, looking at how you can use macro variables and logical programming to actually get a bit more out of the machines rather than just making parts. So there we go. We've done that pass, that's gone round. Let's grab our drill, and we're just going to drill 2 holes in the top I'm sure everyone out there is just enjoying watching a machine run for a bit. I know I do, but I understand that I'm a bit of a
We all
spec.
do.
We all just love
Yeah.
watching machines run.
I'm sure that they wouldn't be watching us talk live over a machine if they didn't like it.
There we go. Lovely little drilling pass there. So we've just finished that one. Let's quickly jump back onto our controller. Here we go. And let's have a look at our cycle counter that we've got. That should equal 1 now. Again, I haven't looked at this yet, so you're looking at this the first time with me. Let's go back to our current commands. Here we go. Brilliant. We've now got our cycle counter. Perfect. It's run. That is brilliant. So we've got our cycle counter. We can see we've ran it 14. It's at 2 because I ran it first and then had to run it again when that file was corrupted. But I could have easily have put a reset program in there as well to take that back to 0. So we're going to run this again now. I'm going to run it in single block and you're going to see that move to 3. So let's go single block. Let's zoom right in there so you can see what's going on.
Rich,
Yes.
we have a question.
Let's go
So
for it.
this is done on a HAS. How would this change from machine running of Mac 3?
Mac 3, I don't know the name of Mac 3's variables. I'm 99% sure it's got them. The little Arduino machine I have at home has got variables, and you program them with the $sign rather than the hash sign. So all you need to find out is how you call the variables and make sure that the calculations that you are doing are allowed. So, for example, I know that on a hash I can even do square root, which is SQRT, if I want to square root a number as well. So I don't know is the answer for Mac 3, but you just need to look at the manuals or do some Googling and find out what is the symbol you need to address to find out where they are. So, sorry I couldn't answer it directly, but someone out there is going to know. I could have told, if you'd have asked me Siemens, Heidenhain, Mazax, any of the others I'd be able to tell you, but I don't know about Mac 3, I'm sorry. Anyway, back to this. So we're in single block, we're in memory mode. Let's run. So we're running through the cycle. You can see we're running through here. And you can see that look ahead's already got us. And we've already gone to 3 on that look ahead. So what it's done is it's processed these lines ahead of time. Now we can get rid of that. So let's go into edit. And let's actually do some manual editing now. I hate manually editing NC code. It's bad practice, but if you know me, you know I tell you to do things that you see me doing all the time. And it's G103P0. That is cancelling look ahead on a HAS machine. Most machines have some way of cancelling the look ahead. On a Siemens, it's stop pre, STOPRE. Different machines have different ways of cancelling that look ahead. Hopefully this is making sense. I'm really sorry if it's not. But what we've got here is different ways of doing macro programming on machines. Again, this was a bit of a risk trying to do this live today, but what are we if not risk takers? So let's go back in single block, back on the current commands. We can see this is now 3 there. Let's see if we had to get right the way down to that line for it to work, if this look ahead has actually done its job. So current commands, there we go. We're going to go down the sequence here. And we're going to see it's looked ahead already because I've got single block on. So you can see how annoying this look ahead actually is. It's reading lines ahead of time and filling in the data. Now that can cause really bad problems if you're using the same hash variable for something twice, because it could have overwritten the value before you expect it to. So that's something to be aware of when you're doing macro programming, is to make sure that when the machine looks ahead, that actually it makes sure that it doesn't start overwriting those macro variables for you. So right, hope people are understanding how we are getting on that at the moment. We're going to jump back into Fusion and have a look at how to do a printed out report on our controller of the actual cycle time that we started the cycle and the cycle name. So let's have a quick look at that in Fusion.
I've got a question meanwhile, Rich.
Yep.
Could you write a macro to change independent features without changing work offsets?
Let me think about what that question actually means.
Yeah, I'm also in doubt. Mark, if you could maybe be a
Okay,
bit
so
more.
let me just elaborate a little bit more on that. You can use macro variables for pretty much anything you want. You can use macro variables to actually do a drilling depth. You can use them to command the machine to move. So you could do G1. Let me show you. Let's again. Any of you that watch my live streams know that I end up doing more stuff that I didn't plan on doing than I did do. This is inspect surface. Um, this is my bread and butter. This is, and Paolo's thinking, God, Rich has gone off on a probing tangent. We're going to be here for a week, but I'll try and keep it quick. So what this is doing, this is basically the how I learnt macro programming was doing probing. So let's quickly make a cycle called number 3, and let's take a quick look at that NC code. Now, for some of you now, you might fall off your chair when you look at this NC code because it's going to probably look like nothing you've ever seen before. But this is really what macro programming is all about. So,
Mark specified saying for moving holes, for example.
for moving holes, exactly that. So, if we look here, what we're doing is we're assigning a value to hash 2, we're assigning a value to hash 3, and a value to hash 4. We're then commanding the machine to move to those values. So let's write a bit of NC code ourselves here. So if we wanted to go, so this is going to be hole 1, and we're going to do hash 1 equals 10, and that's going to be our X position. And we're going to do hash 2 equals minus 6. Helps to put the equals in, doesn't it? Equals minus 6, and that's going to be our Y position. And then we're going to do hash 3 equals... I'd really be brilliant if I could actually type on a keyboard, wouldn't it? Hash 3 equals... I'm going to do 5, and this is going to be our Z safe. And then we're going to go down to hash 4 equals minus 3. And this is going to be our Z depth. So what you could do now is you could write this as a little program that lives on your machine, and all you ever have to do is just adjust these values. Because what we're going to do now, we're going to do G1 equals, G1 X hash 1, Y hash 2, Z hash 3. So that is exactly the same as programming G1 X10, Y minus 6, Z5. Are you all with me on that? I hope you are. Again, I never thought I'd be sitting here hand typing out NC code on a live stream, but that's the way the world takes you. So what we've got next, so what I do in my program now, let's put that in brackets, because that was just our translation of what that would mean, is that's going to be my pre-positioning move. So that's going to position over the hole, and then now I'm going to do my drilling cycle. So what I want to do now is I want to do exactly the same as that, but I would then want to go to hash 4, and that's going to be my drill. And let's copy that and put that back. That's going to now be my retract. So thank you very much for that question. I wasn't planning on hand typing out a load of NC code and making a bit of a fool of myself while I struggle to remember how to program NC. But so what we're going to do here now is we're going to move the machine to X10, Y minus 6, Z5. We're then going to go down to Z3, and then we're going to retract back up to Z5. So what we can see there is we're basically just moving over a hole, drilling down, and then drilling back up again. So hopefully that answers the question on can you use a macro variable programming to program holes and programming moves. Yes, you can use them for anything you like. Hope that answers it. Right, feel free to try and stitch me up with some more questions.
We have a question on the type of HAS machine we're using.
Okay, the type of HAS machine we've got here is a VF2 SSYT. So It's a Haas.
I'll type it. I'll
It's
type
a
it down.
it's a three. Do you want me to type it in, Paolo?
No, I'll type it. It's okay.
It's a three-axis machine. For those of you that have watched other live streams, notice it's normally got a multi-axis trunnion fitted onto it. But that's been removed at the moment for the Autodesk University demonstration that I did. So that's been removed at the moment. I'll actually put it back on tomorrow morning. Could do a live stream on that. So at the moment, that's what we've got. It's just a basic three-axis machine. It's got a 10,000 RPM spindle. It's got 31 tools in the tool changer. Anything more you want to know, just Google Haas VF2 SSYT, and I'm sure Haas can tell you a lot more about their machine than I can. So anyway, that was how you can use macro programming to actually go to positions and drill. Hopefully that was useful. Right, what I've got now is I've got the cycle counter in Fusion that we saw here before, which is doing the little counting up for us. And I'm now going to look at something a little bit more in depth. We can also use macros to do something called dprinting. So dprinting is the way that Haas and other Fanuc machines create a text file. The machine itself creates a file. So what I need to do here, I need to open the port. That's what popen stands for. I'm going to dprint the text cycle start. I'm then going to dprint the text that goes year, month, day, day. Then I'm going to output hash 3011. And on a Haas machine, that is the parameter that stores the date. Easy as that. The next one I'm going to do is the time, which is 3012. And that stores the time in the format hour, month, second. Now, there's something I need to show you here as well. Because what we're doing is we're outputting two different types of things. We're outputting strings here, which are these letters, they're strings, and then we're outputting a combination of strings here and integers, because a hash parameter can only have integers or numbers. Think of strings as a mixture of alphanumeric characters, and then an integer has to be a number, a whole number. So again, I'm suddenly realizing this is a big step up from our previous live streams. So hope everyone's going. I did warn everyone this is an advanced session. Hopefully you're getting something out of this. When I output the value of an integer, I need to tell it how many decimal places before the decimal point and how many decimal places after the decimal point. So it knows how to format that integer. And it's going to be 6 before and 0 after. So let's do that there. We want 6 before and 0 after. That's what we've got. So let's run this on our machine. Again, I wish I'd had some time to practice this, but you're going to go through this with me. We're all in this together. So let's make a new NC program. We're going to check that it's got all those operations listed. Again, if you're not using NC programs, I really recommend it. It's just a much easier way of being able to output lots of different toolpaths, and you can see what toolpaths are being output. So I'm just going to quickly grab the old memory stick. Again, I normally work on the PC that's networked, but at the moment, I'm not on that PC, so unfortunately I'm having to use a good old-fashioned memory stick to run the programs backwards and forwards. Mark Armstrong, I should be able to write that macro now. Cheers, Mark. Well, if one person out there has found this useful, I consider myself job done. So thanks very much. Please hit me back up in the comments, or I'm always lurking on the Fusion 360 manufacturing forum. So please give me a shout out on there and I'll happily help you out with this. It's something I actually find really interesting. Paolo's thinking he's that sad he actually does find it interesting. So give me a shout and I'll hopefully help you out if you've got any problems with it. So we've got our NC code now. Let's take a quick look at that. Here we go. So we've got our cycle counter. Oh no, we haven't. We've got our thing first here. So we've got our cycle start. We've got our date with our hour, month, day. We're going to print out the value of that macro variable, or that parameter, I should say. And then we're going to have 6 characters before the decimal, 0 characters after the decimal. If you're wondering what an asterisk is, for Fanucs and Hasses and so on, those types of machines that use Dprint, they use asterisks as spaces. It will all make sense in a minute, I hope. So, brilliant. Let's head back over to the machine. Let's run this code, and we can see what's going on. So, I'll put you all back inside the machine. I know that's where you all want to be living at the moment. Back inside some real machining action. I'm sure Paolo wants to be in there as well, because how long has it been since you've actually seen a machine in the flesh, Paolo?
Too long. I was gonna say that, too long. It's been since maybe February, when this whole, let's say, situation with limiting to people's movement started. So I really I miss Swerve flying up.
Right.
We should be able to see your screen fine. Yes, by the way.
Can you see everything okay?
Yeah, we see the machine, we see the part.
Brilliant. That's exactly what we're after. So, again, just forgive me, everyone, because I am not a quick machinist. I always like to make sure that I'm being safe, um, especially when I'm on live.
Better safe than sorry, I guess,
Oh,
regardless of us being live.
to be honest,
Even
I bet everyone out. I bet this would be the most watched YouTube live stream if this probe just crashes through the part now. Right, here we go. Probe's on, everyone. We're now going to probe down. So again, this little program that I'm running now basically just means that it's going to keep going down 2 mm every time. So it's going to just run down and go down another 2 mm. So that's why I've done this. So we can just quickly keep machining more and more off this block every time without worrying about having to keep swapping parts over in the vise. There we go. Bit of machining action. It's what we all want in the middle of the day. Or whatever time of day it is for you. I'm not quite sure where you are. Where are you from? Let us know. It'd be interesting to see how late people are willing to stay up to watch me, or how early people are willing to get up. Right, brilliant. So we've done our bit of face milling. We're now going to get our M mill out of the tool changer, and we're going to quickly whiz around the block. There we go. That's whizzing around there now. And then we're going to get the drill out the spindle now. So let's get that drill out the spindle. We're going to drill 2 little holes in this part. There we go. And there we go. Perfect. So that is our cycle finished. And what it's going to do is it's going to run round again. So what I've asked it to do is just to do exactly the same cycle. Keep going round. Again, let's just go nice and gently into this. There we are. Perfect. So brilliant. What we can see now is it's run that cycle. We're going to finish that off and run it again. And what you will see is another line in the results file. So again, we're quickly going to probe that block. We're going to bring that down. Come on, nice and quickly. The viewers are watching. Come on, probe. So, right, to probe that now, it's going to drop that down again. I'll let the face mill go, and then we'll quickly just look at the controller, and we'll have a look at the results file it's printed off for us. So what we have effectively done here, we've run 2 parts off, and as a result of this, I'm going to have a file that's told me exactly when, what time and day the cycle started, and also give me the cycle counter as well. So the whole point there is that you've hopefully got an insight into how, if you run a shop, you could actually use this to keep track of how often the machines are run, what parts are being run in the machine, and so on. Well, I'm going to stop this now, because I had no idea that I'd been going for 50 minutes already. Time flies when you're having fun. Right, so here we are, back on our controller, everyone. There we go. Zoom in a little bit there. Now, I need to find where our results file is. Again, if you've got a HASS, watch my video on how to set up inspect surface on a HASS next generation controller, and that will show you all of the Dprint functions and how to set those up correctly. So I'm going to go to this one here, select program, and edit, and we're going to get to our right down to the bottom. So what you can see here now is we've got at the end of this file cycle start. Let's get right into there. Cycle start. We've then got to tell me that the cycle started. We've got the date in year, month, day format. So it's the 26th of November 2020. We've then got the time in hour, minutes, seconds. So for me, it's 45 minutes past 2. So how brilliant is that now? And I go down again a bit more. Oh, and I'm at the bottom of the file. So if I was to run the cycle again and again and again, I would now end up with that format constantly repeated throughout the cycle as I went. So the idea being there is that you can actually implement this on your machine, in your shop. You can try and make yourself cycle counters. You can make yourself that little format. I'll actually pop that in the description, the variables that I've used, so you could copy and paste that into your own NC code. And then the idea is you can just keep track of what your machines are running in your shop. Imagine you had a bank of 10 or 15 Haas machines and you wanted to see how many parts they were making in a day. This would be a really nice, easy way to do that rather than having someone manually write down how many parts they're making. You could look at the exact cycle time because you could get it to print out the date and time at the start of the cycle and at the end of the cycle. So I hope this has been useful. I'm going to jump back over to Fusion to show you one last thing, and then I'm going to let everyone carry on with their day. So
We have a
now's...
quick question, Rich.
Perfect, go on, Paolo. I was about to say, start asking questions, everyone.
Yeah. How could you use these to machine serial numbers into parts?
Oh, okay. So what you need is you need a machine that can do an engraving cycle from a macro variable. Now the Haas can do that. So I'm not sure about the exact code. I'll look it up and I'll put it in the description. But you can give it a can cycle with the macro variable as the value. So you might go, again, I really don't know, but it could be, let's say it's going to be M328. So you're going to do M328 hash 10,062, and it's going to put the engraving of that value variable in there. I really like that idea. I'm going to have a look at how to do that, and I'll put the how to do it in the description. If I really like it, I might even make a video on it. So thanks very much for the question. Again, ask some more questions, everyone. I really want to know how has everyone found this. Again, I think this has been very poor on my part, so I hope everyone out there has followed along with it. We've had a few technical hitches, but hopefully we can carry on. So let me know, pal, if any questions come in. But what I'm going to talk you through at the moment is I'm going to put the cycle counter above there, and then I'm going to duplicate this, and then I'm going to drop that down to the bottom here. I'm going to delete that one. I'm going to call this cycle end, with date and time, and then I'm going to modify this to say take out the P open because I know I've already opened the port, and I'm going to call this cycle end. So brilliant. That what we've got here is a cycle start and a cycle end in our program. So what we're going to see is we're going to see at the start we're going to be told how long it started from, and at the end how long it took. And for those of you out there now that are really thinking about how you can utilize this, think about this. You could have stored the value, the date and time, or sorry, the hour, minute, second value. You could have stored that in a volatile variable at the start of your cycle. At the end of your cycle, you could have taken the end hour, minute, second, taken away the value that you started with, and you could have calculated your cycle time. So I'm really trying to show you that once you know how to do macro variable programming, the possibilities are absolutely endless. They really are. You could use all of this to start looking at really honing in on your machine tools, looking at creating logs of what they're making and when. You know, I could even have gone in here, and if I edit this, I could have called, you know, I could have gone Dprnt, part, asterisk, name, asterisk, equals, asterisk. Again, asterisk is a spaces, everyone. YouTube live. So it would even now tell me the part name on there as well. So you could track how many of the parts were getting made and all sorts. Right, have we got any more questions to end on, Paolo?
Well, we have quite a few people excited about the idea of a video about that topic that Carl suggested.
Thanks for that, everyone. That's going to be a tricky one, but I don't know if it's possible. But I'll do my best to find out. I know they do
We'll
some
try.
sort of cycle. I'll find out.
We'll look at it. We'll look at it. Then Mark saying that the engrave can cycle command is G47 on a HAS. And Peter was saying that we should add a console to YouTube so they can write the G code. And just in case they go too heavy, we can push the red button. But I said, I think it's a great idea, but Peter thinks that you wouldn't like it as as a way to run a line. Just be there in fear that something can go wrong.
Yeah. I'm sorry, but yeah, I don't like running anyone else's NC code. Never mind letting them run my NC code on the machine. But yeah, everyone. So please, if you want to know more about this, again, I've tried to cover a topic that's taken me years to learn in an hour. I've probably got far too carried away. So please let me know if you want a more structured, in-depth lesson on this. I can go back to basics and we can do a series. We can do a couple of series over a couple of weeks about macro programming and how to do it. These live streams are really out there for you. They really are. We want to make sure that you're getting the content that you want out of it. I just love seeing people that enjoy what we do. It really helps us spend the time on doing this, because you might not know, but this isn't mine and Paolo's job. We have other things to do, so we have to try and make time for this. So it makes it all the worthwhile when we see out people out there really enjoying it. I'm going to post the link again to the Christmas Cam Challenge. Please enter. It's a design for manufacture challenge. So I'm going to be judging them on. I'm going to be judging them on how sort of applicable to manufacturing they are. Doesn't matter if you make the best design in the world. If we can't make it, then sorry, I can't make it. It's as simple as that. So yeah, brilliant. I think I'm watching the chat on here now, and we just seem to be having some good feedback. Everyone, thanks very much. We really appreciate all the support. Wishing you all a good day, and stay safe, and see you again next time.
Thank you, guys. Thanks, everyone, for joining. Cheers.
Right, ended.